Alright, so let's take a look at some word problems. This word problem we're going to be working with exponential decay. It says a scientist begins with 250 grams of a radioactive substance. After 170 minutes, the sample has decayed to 32 grams. Write an exponential equation representing this. And to the nearest minute, they want to know what the half-life of this substance is. All right, so the equation we'll just say A of t is equal to A sub 0 e to the kt. Okay, so we need a function. All right, so we need to know what A sub 0 is, and we need to know what k is. T is going to be our variable. Okay, well, we know what A sub 0 is. A sub 0 is the initial amount. It's the amount you started with. And so here it says a scientist begins with 250 grams. Okay, so we know that's A sub 0. And it says after 170 minutes, the sample has decayed to 32 grams. So what that means is the 170 minutes, that's the time. So what it's saying is if we take the 170, plug it in for t, and evaluate this, we should end up with 32. Okay, so basically that's saying that A of 170 is equal to 32. So let's plug everything in and see what happens. So I have A of 170. Now let me switch colors. So I have A of 170 is equal to A sub 0, which we know is 250. That's the amount. That's the initial amount. Times E. Now we don't know what K is, but what are we substituting in for T? The 170. So that's 170K. And that, after we evaluate it, that should equal 32. Okay, so look what happens here. We have an equation we can solve. Okay, so let's solve this. And so that's going to be 250 e to the 170k equals 32. So I'll divide everything by 250. And so I get e to the 170k equals 32 over 250. Yes, you can reduce or, whatever, but I'm not going to worry about that right now because all we're doing, we're looking for k. We're going to get a decimal for it anyway. Now, do we remember how to solve this? I have e raised to a power equals some number. So this, remember to solve this, I'm going to take the natural log of both sides. Okay. Take the natural log of both sides. So over here, I just get 170k. Now, to refresh your memory, the natural log of this, remember if you have the log of b to the x with base b, you see when these are the same, the base on your exponent and the base of the log, when they're the same, your answer is just your exponent. Well, remember natural log e to the 170k. Remember, natural log is the same thing as log base e. And these are the same, so my answer is my exponent. Okay? All right. And that equals the natural log of 32 over 250. And so I divide both sides by 170. See, basically all we're doing right now, we're solving for k. And so k is equal to, and then I'll need to punch this into my calculator. Okay, so this is what I get for k. Now it goes out to more decimals, but for the video, I'm going to round it to 4. Okay, this is a 0. Now, another thing you can do, you can also just leave it like this if you want. Okay, but I'm just going to punch it into the calculator and get k to be a decimal. All right, so now we have our equation. Remember, it was a of t is equal to a sub 0 e to the kt. Well, if you remember from the problem, a was 250. That's what we started with. And now we know k is negative 0.0121. So my function is a of t is equal to 250 e to the negative 0.0121 times t. So that answers the first part. Okay, that answers the first part. That's our function in terms of t. Now they want to know the half-life. Okay, they want to know the half-life. So, well, that's easy to do. Well, if this is our function, we've got 250 e to the negative 0.0121 t. Okay, so we need to know how long it takes, what number can we plug in for t so that we get an answer of 125, half of what we started with. See, that's half of the 250. Okay, so now we solve for t. So I divide everything by 250, and so that's going to be e to the negative 0.0121t equals 0.5. And so I'm going to take the natural log, of both sides. And so remember, I explained this earlier. That's just negative 0.0121t equals natural log of 0.5. Divide both sides by negative 0.0121. And I know I rounded this to 4 decimals. I would recommend just writing all the decimals. Okay, so we get t is, and then I'll have to punch that into the calculator to see what we get. So let's see, negative 0.0121, and that gives me 57 point, I will round it to 3 decimal places. Okay, and so the half-life, if you notice, we're in minutes, and so the half-life would be about 57.3 minutes. So close to an hour would be the half-life. Okay, so hope this video helped. Check out my other videos. I'll do some more of these, and they'll be a little bit different than what this one is. So check those out. Like and subscribe, and thanks for watching.